The second time I've had to restart it today.
Oh, tell me about it, huh?
You're wrong, you're not gonna pick that up.
No society still working with
Hey, why are we not like getting ready to go here? Usually you guys are yelling at me to get going. We're on our last topic for the section. What? Yeah, I had to restart my computer. So the last portion of the section is absolutely nothing like what we have been doing, and that's fine, but I don't know why it's put in this section. So I wrote them over here so we could kind of use them while we're doing the problem, but otherwise they're in your packet. And basically it's just how to do a derivative for if the base isn't e. So when we had e to the u, that was fine, that's an easy enough derivative. But if we have a number that isn't e, there's a formula to follow. And then if we have a logarithm that isn't base e, so natural logs are the only thing we've done so far. We've done ln of u. But if you have a regular log with a different base, then we have a different formula to follow. So the formulas aren't great, but they're actually not that different than the e-based ones. So there's nothing wrong with how it's written up here in the packet. To me, this looks more confusing than like what I wrote over here. So if we had e to the u, the derivative of e to the u was rewriting e to the u times the derivative of u. Well, now if you have a base number that is not e, so an a represents a number that isn't e. So whatever number is down here, the only difference in the derivative is that you also have to multiply it by ln of that base number. So this theoretically still works if it was e to the u, because ln of e is 1. So this is the full derivative.
Does that work if a is a variable?
No, no.
Okay.
Thank you. I guess I should have clarified that. A has to be a number, a constant number.
Okay.
There is a method, if you have a variable to a variable power, doing the derivative is kind of horrible. We will not have to do it.
All right.
I just use the power rule.
Power rule only works when the power is a constant number. So this, the u indicates that that's a variable. So if you have a constant number to a variable power, this is how you would do the derivative. If you have a variable base to a constant number power, that's the power rule. It feels like they should be the same, but they're very different setups. And then natural logs, I heard you guys need a re-explanation of natural logs, or just logarithms. Okay. So a logarithm, just any logarithm, is a way to solve for powers. So log base b of u means b to what power is this answer. So the power is the actual answer we're looking for, and there is no way of solving for those, so they set them up as logarithms. That's what a logarithm is. Theoretically, you don't have to know anything about logarithms to be able to do the derivative. I mean, I guess knowing the logarithm properties would help, but you don't even have to know what logarithms are to do this. today and tomorrow, when we get to section 5, are very heavy formula sections. So like this, you just have a formula to use. And you're gonna take your problem, which is gonna have information in place of A, information in place of U, and then plug them into the formula. And that's what tomorrow is as well. So these are generally what you look forward to on tests because they are very easy and straightforward. And when I say easy, I don't mean the information will be easy, I mean the setup of the problem. Okay, let's do like the examples down below, which I think we should go through pretty quick, but we'll find out. What? Oh, okay. I thought you were asking me something. Is this the respect, like even asking me if I got a degree or went to college?
Never asked it in a way that you could.
Not in a way I could hear.
Wanted
Yes, oh, I see, okay. Yesterday,
We made you say.
I went to 2 colleges. Bemidji State and Full Sail. What is this? Oh, I got it. 5, table 5. You guys get off track so easy. So table 5. I'm going to skip the easy problems. We're immediately going over to the ones that require you. So we've got 4 to the power of 3x. So we have a constant base, which is 4. The u, which is the power, is 3x. Do you, would it be helpful if I wrote down the generic formula here in the problem, and then we fill it out from there? Okay? Okay, so on this particular problem, A would be 4, because that's the base. U is going to be 3x. So your table can figure out how we want to answer this, who's going to answer it, whatever. I don't know if we do nose goes or something, I don't care. I guess so, he's the only one that even touches his nose, which is the opposite of nose goes, but we'll go with it. Jason,
Yeah.
help me out.
Okay. So like since like the A is like 4,
Okay.
like ln of 4
Perfect,
times like 4 to the power of 3x.
good.
Times like
Derivative of
yeah,
3x,
which is like what is that 3?
correct,
Yeah.
done. If you want to clean up the answer, the only way it sort of cleans up is 3 times ln of 4 can go together as 3 ln of 4. But that's pretty much it. I don't even know if 4 to the 3x should be first or last, but it doesn't really matter. The answers aren't going to look good, but they're very easy to find. Is it helpful for now if I write the generic formula down first so we can kind of just fill it out? So what should happen is after a little bit, you'll get so used to the generic formula that you just sort of memorize it, / you need to purposely memorize it because you're not given anything. It is by far the worst part of calc to me. I think calc would go much better if you guys would always be given a formula sheet. But there's good and bad about having a formula sheet. Lena, let's roll. No, that was not a roll. You picked it up and dropped it. You still did that. Where did you guys learn how to roll? There we go. 4. That is true. Does somebody else want to roll? Lena thinks it's too difficult. Nice. She's going to actually pick it up and roll it. Probably. Okay, table 4. Do we want to do problem C or D? C? All right, sounds good. Okay, I'll write down the generic formula, all right. First, I guess maybe what should be helpful is, can you guys identify what would be A and what would be U? What's A? 5, the base is 5. The U would be X squared, okay. So pretty much just fill it in. Perfect. So you guys should be getting to the point where no matter how complicated or difficult the formula is, when you're given a formula, you should be able to fill it out. Why are we on our phone? Put that away. I don't want it. Put it away. Okay, let's skip D, because D is, in my opinion, is no different than B or C. The only difference on D is that the very end would be negative 2x instead of 2x. So let's go to logarithm problems. That's the only difference on this next page, is these are the logarithm problems instead of exponential. Yeah, but who do we got? 7. Okay, I put the generic info up there. B represents the base number, so on this problem, what's that? 3, good. How about U? Sine of x. It feels 100, it's very weird. I mean, it's a strange formula, but U is sine of x, so we just fill it out. What's the derivative?
1 over ln of 3.
Okay,
Minus 1 over sine x
yep,
times cosine x.
that's it. Now, on this problem, the only thing I could see possibly happening is the cosine and the 1 over sine could be combined together to write cotangent. Because sine over cosine is tangent, cosine over sine is cotangent. That's about the only thing I could see possibly being done. You guys gotta not sit by each other if you can. So that's possibly about the only other thing I could see happening. But otherwise, generally, the derivative on that step is pretty much all you can do. Okay. Actually, why don't you guys just see if you can do C and D? I wouldn't even doubt that at this point you've already figured out the plug things into a formula. And the information here is weird. On D, my tip would be to use logarithm properties before you do derivatives. Focus on your packet.
Typically it's base 10, it's not 7. So if there's no base stated, is it just 10?
Yeah, if there's no base number there, it's a 10.
I assume, that's what I already did. I remember the base.
I think you make it's
Oh yeah. Dude, that was so awesome. I wish I was like in the NFL at that time. I was. was, and I lived in Seattle at that time. Oh, Poggers.
First one that I came up with.
Oh, shoot. I didn't know to do that.
What what's the derivative of 3dx? Do I have to add
That top formula. ln of 3 times.
Yeah, just 2x plus
ln of 3 times.
Oh, I was thinking of that.
C should be pretty quick. The only part about C that some people get stuck on is the derivative of 3 to the x, which we literally just did 5 minutes ago. Yeah, my guess is it's not automatic to you yet. Like when you see 3 to the x, you're not just immediately trying to write the derivative because you haven't done enough of them to make it automatic. So I'm not saying that as a negative that you get stuck on derivative of 3 to the x because we've just started that. Second one, it makes a huge difference if you take the cube root portion out as a power before you do derivative. Because the derivative of cube root of 2x plus 1 is far worse than doing the derivative of 1/3 times the logarithm. But the answers would simplify down to the same thing. So even if you didn't take the 1/3 out, the answer would still simplify down the same. Okay, this actually is all there is for the note. Like this section, if I rushed it, we could have done it in 2 days. I just don't think it would have gone well to try to fit it in 2 days. So I purposely wanted to do the first topic, the first 2 days. So derivative of inverse is what I wanted to do as one topic. And then today, these formulas. So we have, I don't know how much time. We have 24 minutes left. In your homework, question 10 has nothing to do with this section. I am unsure why question 10 is included in the homework. Yep. I don't know if it's meant to be a review question. If you would like to do 10, go ahead. But just know that question 10 is not, oh, look at that. It's just being crossed out before even attempt. Yep. Okay, I wanted to let you know 10 was optional. It is a very large problem, and it is not any of the new topics. If you already did 10, you are just that much smarter. Okay, I'll gladly help you with any homework questions for the next 25 minutes.